Hey everyone, today we are lucky to have Kylan, who's the co-founder and CEO at Inworld. Mate, thanks for joining us.
Yeah, thank you so much. Happy to be here.
So Inworld is at the forefront of AI consumer applications. Maybe you can tell us a little bit about your vision and what you're building.
Yeah, so we both came from Google. And so my job when I was at Google was actually to help apply AI across Google products. And we saw very early momentum of things moving into business-facing, professional-facing applications. And our team has always thought that the benefits of AI are best going to be realized when they reach everyone through consumer applications. And so we effectively started out kind of trying to solve the technical problems behind that. And so we started out with gaming and media because LLMs were great for conversational AI. We started working with groups like NVIDIA, Xbox, Niantic, Disney. And so we really kind of honed a lot of the technology, I guess, and like what does it mean to serve AI for massive million consumer scale. And that continues to be kind of the vision behind what we're doing, is just making sure that it's possible to bring the best of AI to everyone in fun form factors.
Yeah, so you've just had an amazing launch with the AI runtime. Maybe you can talk a little bit about how you went from gaming now to sort of pure infrastructure for consumer applications.
Yeah, so it was really interesting. As we were working with these gaming and media partners, what we realized was a lot of the infrastructure being built is for enterprise-facing things. Cost, quality, and latency are all very different in enterprise versus consumer context. You know, cost, it needs to be under dollars or under cents per day per user. You know, latency needs to be under 500 milliseconds. Consumers surprisingly actually are less patient than enterprises when it comes to these things. They're going to bounce if it takes too long. And then quality is very different, right? So when you watch your favorite show or you play your favorite game or you watch a movie, you want to be entertained. When you talk to ChatGPT or all these chatbots now, it's about factuality and something to be very accurate. And so we realized there needed to be a lot of customization at that level as well. And so while we were building a lot of things around characters and that, working with these large companies, we also built out the infrastructure to actually power that consumer scale. And kind of along the way, we realized that was not just valuable for us in solving our own problems, but for a lot of other groups. And so larger consumer applications started coming to us. And we realized this infrastructure that we built to serve ourselves was actually more valuable for all these other companies as well. So we decided to open it up.
Yeah, so that maybe specifically on the AI runtime, like what is that product? How do people, developers interact with it?
Yeah, so effectively what it is it's a graph-based solution. So you build within an SDK, you go in and you can basically build any application and then it auto scales. So the core part of that is that it handles kind of the complexities of when you're scaling up workloads, you usually have to do a lot of re-architecting. And so we can scale it up much more easily because it has the auto scaling built in. And then it also automates a lot of the ML ops. So what we found was a lot of teams were spending, and we were spending a lot of time on maintenance rather than actually new product development. So we wanted to automate away a lot of that maintenance. And then finally what we found is for any consumer application, anybody you've ever seen, touch consumers, they realize you can never guess what actually works. You got to experiment lots. And so we also designed a way to be able to stand up these experiments and launch without code changes so you can just test what works with your users and then scale it up automatically.
That's awesome. Maybe you can talk a little bit about what type of LLM and AI-related use cases are you seeing in consumer applications that are using the AI runtime, but also other stuff you've done in the past? Yeah,
so the really interesting thing when any consumer app is, it can always be broken down to some kind of model graph. So you've got groups like Streamlabs, for example, who created this real-time streaming assistant. So it's taking into account real-time game state, visual information, audience, like text, all in real time, having to have 500 millisecond response times. And so there we had to build this very complex model graph and get it working super fast. Then you've got status by wish roll, which is actually simulating a Twitter-like experience, generating content like real characters. So there it's a lot more LLMs, you're actually understanding broader context, you're generating achievements. But at the end of the day, it can all be broken down to things like speech to text, LLMs, text to speech. But the interesting thing is what we see everybody doing is they start with default models. So they basically start with their favorite, big provider models. And then we eventually move over to custom models. And that's when it becomes really important to be able to kind of actually control not just the model, but the inference stack behind that. And so as we move customers onto those custom models, that's basically when we're starting to engage, I guess, more on the
and I think that was where we started, right? And I know Igor and EJ will talk a little bit about the infrastructure behind that, but the custom TTS model is actually where we started, and then now we're beginning to look at broader LLM
every model. I mean, there's at a certain point, every model can be hosted, every model can be optimized, and I think what we want to figure out is, we clearly really broke some boundaries in terms of the text-to-speech model, and so now how do we do with LLMs? How do we do speech to text? How do we do every other model? Because at a certain point, that means that every customer gets the best experience and their users get the best experience too.
We've had an awesome partnership, but maybe let's go through how did it get started? Why did you choose Modular? If you can tell us a little bit about that, it'd be great.
Yeah, so we knew you guys from Google, which helped a bit because there are a lot of people, touching the AI developer tool and infrastructure space.
We know it pretty well.
You probably know as well as I do. And so when we were engaging with this, we were realizing, what are the problems that we don't want to solve, right? So we want to solve the model level. We want to be able to solve the infrastructure. We want to solve some of the application stuff, but we at some point don't want to handle that last mile behind the hardware, the inference, which is super important. And so as we were working on our new text-to-speech model, we realized that there was a huge opportunity for optimization there. And we weren't necessarily the people to do it ourselves. And so that's why we were happy to engage with you guys. And basically, I think we broke some boundaries in terms of what you can actually do with a text-to-speach model together by having our models in your inference.
Yeah, and I think the interesting thing is, and maybe you can talk a little bit about it, was you trained your own custom model. And then we integrated that directly onto the modular stack and then scaled it. Talk maybe a little bit about what we were able to achieve with the TTS outcome.
Yeah, I mean, what was crazy there is we had a new model architecture, an LLM-based TTS. You had new hardware, B200s, nobody really touched them yet. And so you're like, well, there's something that can happen magic in the middle there.
Well, in fact, I think when we first started, the B200s weren't even...
No, exactly. Yet, right? I think we had 4 weeks to be able to actually land on the B200s, which was pretty crazy. And now, it is crazy in terms of the efficiency they were able to get out of that model, even compared to some very large providers. And I think that just speaks to the fact that we were able to do that in a few weeks shows a lot of promise for what we can do now in terms of LLMs and lots of other different model types as well. Yeah,
and I think that's a good segue. Oracle's been a wonderful cloud partner. Why don't you talk us through a little bit about why you chose Oracle? What are the advantages of Oracle?
Yeah, so when we were standing up, a lot of it was kind of, we had to take this huge GPU outlay, both to train our own models and host custom models for customers. And so we needed to get a huge cluster stood up and also have the flexibility of a partner who was able to kind of move with us into the future. And so Oracle came in, they had a great team, they had a great offer, and of course they had great optionality. So that was a huge thing for us. So we started out, we've got the B200 with them, super awesome, but also they have the optionality to move on to AMD and other chips. And that's important because when you're thinking about this consumer stack, you want to have the optionality across the models, the infrastructure, the application layer, but also the hardware, because you get a lot of options in terms of how you want to optimize the specific application. And so that's what we found really valuable to Oracle, is that optionality.
Yeah, and at the end of the day, a lot of the price in inference is driven purely from the hardware. Right. And so it's unique that they have both NVIDIA and AMD. Right now they have B200s. The MI355 is coming. It's an exciting piece of silicon. And I think we're going to see a demo in a little bit, but the fact that Modular can scale from NVIDIA across to AMD, they're a natural partner.
Yeah, and I think that also speaks to how wonderful it is to work with you guys too, because we have the model, we have the inference stack, and we can port that over to different chips. And so then we get to take advantage of that optionality, which is a huge piece. And I hope we figure this how to automate this in the future, and we're just deploying it to whatever hardware works at a given time. And I think this just improves the end user experience. If you think about these games and everything else, to get the best experience for end users, we need to have the most optionality at the back end as well. And that also comes into the inference stack and how we're with Modular, the models that we're training. And I think just that is actually how the ecosystem evolves together.
Yeah, and I think that's right. And huge thanks to OCI. So now what we might do is pass over to EJ and Igor, who are going to run through a little bit of the infrastructure that we've just talked about.
Thanks, Tim and Kylan. Igor, it's great to have you.
Thanks for having me here.
Cool. Can you tell us a little bit about what Max unlocked for you when you were deploying your TTS workloads?
We started with vanilla VLM solution and quickly realized we couldn't really fulfill our requirements for latency and throughput. What Max helped us with is actually to make the TTS model real-time. That is, to deliver audio chunks faster than the client can actually play the audio back.
And I think we had a pretty cool joint blog post on the Inworld blog that talked a little bit about what the actual performance numbers were. Can you tell us a little bit about what those were?
The way how we measure text-to-speech inference speed is basically how much time it takes to get the first audio chunk on the client side. And that number went down from 1 second below to 300 milliseconds with the help of the Max server. Not only that, but also we were able to significantly improve the throughput such that the actual cost of owning the model serving for us decreased by almost 70%.
Wow. And I think that's the coolest part, that you can actually pass on those savings over to the end user.
Exactly. The cheaper it is for us to serve the model, the lower the pricing of public API we can make.
Yeah. And one of the key features of Max that we like to sort of pride ourselves on is that it's really easy to get started with. Can you tell us a little bit about integration and what that was like for you guys?
Exactly. It was super simple, actually, because we serve our TTS model using Python. And because Max is compatible with Python directly, it was super easy for us to just do the integration without any additional glue code to be written.
So that's the TTS model, but I think Tim and Kylan also mentioned LLMs. So can you tell us a little bit about what you're doing with LLMs, what the challenges have been so far, and where you're sort of headed?
One of the most popular use cases for Inworld to serve large language models is to provide the public API for custom fine-tunes that the customers use. And in addition to classic challenges of making them fast and cheap, we also have a challenge that we never know when the bursts of traffic are happening, and we have to be ready for them. One of the challenges for us in particular is that neither us nor our customers know when the virality can hit.
Yeah.
And we have to be ready for spikes in traffic. And that makes us to create very sophisticated solutions to be ready for these events.
And of course, also when you spike into traffic, you're also bursting into more expensive GPUs as well.
Exactly. Right? Whenever you have to take care of additional traffic spike and you do not have a capacity allocated, you have to pay for on-demand prices, which are much higher than the regular prices, basically.
Okay, so this actually might be a nice segue, but I know you guys are exploring AMD GPUs as well. Can you tell us a little bit about why that is?
Yeah, so an ability for us to actually serve our LLM stack, not only on NVIDIA GPUs, but also on AMD GPUs, is that we are much more flexible in a way how we can manage this spare capacity for burst of traffic. And the fact that Max supports different types of hardware without changing the code has made our life so much simpler.
Yeah, and so normally to have both an NVIDIA stack and an AMD stack, you'd have to have two different tool chains.
Yeah. So your entire serving stack basically has to be heterogeneous, right? You have to be ready to serve the traffic the same way and kind of not care about the actual implementation details, which is very hard in practice.
Yeah.
And that would have significantly complicated the way how we have to manage this. But the fact that we use the same code and just change the config has made everything so much simpler for us.
Yeah, and I think theoretically, I mean, depends on market pricing, but it also allows you to pick an economical GPU for that burst, right?
Exactly. And actually that helped as well to reduce the final costs of ownership for us.
Yeah.
And therefore reduce the public API costs as well.
Okay. And the last thing I want to sort of talk about with AMD GPUs is you mentioned just changing the config. Can you tell us a little bit more of like how simple that really is?
It's literally as simple as changing one line in the config file for the Kubernetes setting.
Yeah.
So
it's the same container that works pretty much anywhere.
It's exactly that. It's the same container, and we only just have to change one line in the config file.
Wow. I don't know if people are going to believe us how easy this actually is, but Kathy's going to show us a demo, and so let's pass it over to her.
Hello, I'm going to show you that Max can seamlessly be used on any hardware. First, let's start by launching Max on an H100. Let's check that we have a GPU available on this instance using NVIDIA's System Management Interface. Now, run the Gemma 3 27 billion parameter model using Max. The server has finished loading the model, so let's try sending a chat completion request. Now let's go through the same process, this time using an instance with an AMD MI300. Again, check that we have GPUs available using the ROCm System Management Interface. A GPU is available, so let's start up the Max server. Now let's try sending a chat completion request from my local computer. So now we've shown that it's easy to launch Max from different hardware and GPUs. That's it for this demonstration.
Thanks, Kathy. It was so awesome to see how our software is able to scale from NVIDIA across to AMD. Mate, what did you think?
Pretty cool.
Pretty cool. So to wrap up, what do you think is the future of Modular and Inworld together?
I think a lot of it kind of comes down to how we're seeing our runtime evolve. So what we generally see customers doing is they come on and they build a model graph with their favorite providers, whatever they're used to using, and they kind of reach that quality that they really like.
Yeah.
And then as they start to scale, they start caring a lot more about latency, performance, cost.
Yeah.
And so we want to port them over to custom models. And so we want to make it as easy as possible to stand up those custom models, to get them set up, and then to optimize them to heck, to actually get them working as possibly well as we can. And so what I imagine us working together on is building out the amazing pipeline so that as customers get enough traffic, they have enough usage, we can start training custom models. We also then build a custom inference stack for them, depending on their specific cost, latency, quality, desires. And then every customer has not only the best models, but the entire best inference stack and hardware behind that. And that is really what matters for their users.
Yeah, and they get portability out the gate. So
Exactly.
not only do they get all of the power of our inference stack, through your platform, but also the ability to know that there's, incredibly optimized models, and ultimately, particularly with, different cloud providers, you can go across NVIDIA, AMD, and other types of silicon.
Well, and I think the beauty there is there's a few different scenarios. So you can imagine a customer, for example, who has to operate across different regions.
Exactly.
Where different hardware is available,
Right.
but they want to have the same performance. So being able to take that whole stack
Yeah.
and port it over to different hardware in different regions is a huge win.
Yeah.
And also between different clouds. And then the other thing is people are also interested in on-device.
Right.
That's going to be something that eventually
Exactly.
comes.
Yeah.
So imagine being able to take the thing that you have and you love it's working in your cloud, and then as consumer hardware gets adopted that can actually run it locally, we can bring it over.
Right.
And so there's this beauty of that portability that I think actually exposes a lot of this stuff to just new users.
Yeah, and we saw this. I mean, even when we were at Google, we saw this, right? Like in terms of how we went from data center to edge.
Yeah.
And the modular platform actually, today it does certainly execute in the edge environment. That's something that we're going to continue to invest in.
Yeah.
And so not only is it this data center offering, it will go to the edge too.
Yeah, love it.
Okay, mate, thanks for joining us. We encourage everyone to go and check out the AI runtime at inworld.ai. That's all we have today. Thanks so much for joining us, and we'll see you next time.